In this video, we are going to do a two-sample proportion hypothesis test. So we have, in order to help encourage new mothers to breastfeed, a health system decided to implement mandatory training sessions for their staff. So we have, just before the training sessions were initiated, a survey of 71 new mothers found 44 planned to breastfeed. And then after the session, we had a chance to take to effect a survey of 68 new mothers, found 49 planned to breastfeed. So we're going to use the before as P1, and we're going to say after is P2. We want to know whether the staff training sessions were effective in increasing the number of mothers who plan to breastfeed. So we want to know if the P2 is greater than P1. Because we want to know if the after is greater. So we have P1 P1 would be the 44 over 71, and we have P2 is the 49 out of the 68. So we can get our numbers for these. 44 divided by 71 will be about 0.6197, and 49 out of 68 will give us 0.7206. So again, we're looking for whether the staff training sessions were effective in increasing the number of mothers who plan to breastfeed. So we want to know if after the P1, we're going to say that it was higher afterwards, so we want to know P2 is greater. So we have a level of alpha, and what we want to do is we want to set up our hypothesis test. So we have our null is always equal. So our null is going to be P1 equals P2. And our alternative, in this case we say P2 is greater than P1, which is the same thing as P1 is less than P2. So we're going to say P1 is less than P2. And writing this the way it'll go in StatCrunch, we just need to subtract the P2 over. So P1 minus P2 equals 0. See, all we did was subtract this P2, put it over here. And then P1 minus P2 less than 0. Again, we just subtracted this P2 over here. So this is what we're looking for to put into StatCrunch. So we're going to go stat, and we're going to use proportion because we're working with our proportions here. And the way you can tell it's a proportion is we have 44 of 71. So whenever you say something like this of that, that's going to be your proportion. So the key to these often is figuring out which calculator you need to use. So this one we want to do proportion stats. We have our P in our hypothesis testing, so we want to do proportion stats. In this case, we have two samples. And we have a summary. If you had a list of data points, you would use what data. And here we have our successes and our observations. If you do not have successes in observations, you have means and standard deviations, you know this is not the right calculator to use. So we're going to put in our P1, which was 44 out of 71, and our P2, which was 49 out of 68. And in this case, we want less than. And we're going to hit compute. So we see this matches up with what we created over here. So here we have our total counts. So you can make sure you type them in correctly. So we had 44, 71, 49, 68, which match. Then we have the sample difference. So this is the difference between these two. And then we have our standard error. And we have our z-stat, which is our test statistic. So as for your test statistic, that'll be our test statistic and our p-value, which is 0.1032. So that's the important part here. Our p-value equals 0.1032. And we want to compare this to our alpha, which was 0.05 from up here. So in this case, 0.1032 is greater than 0.05. So we have p greater than alpha, which means we failed to reject. So we failed to reject the null. So we failed to reject our null. And what does this mean in the context of our problem? So failing to reject the null means we do not have evidence that the training sessions were effective in increasing the number of mothers who plan to breastfeed. So I'll write that out. And you always want to make sure you're using the context of the problem. So here we have, we do not have evidence that the training sessions were effective in increasing the number of mothers who plan to breastfeed. So we can see our claim up here was that it was increasing, and we do not have evidence that it actually increased. So we can say their difference was only 0.1, so they're very close together. Our p-value was greater than our alpha, so we failed to reject the null. So our conclusion is we do not have evidence that the training sessions were effective in increasing the number of mothers who plan to breastfeed. So that is how you do a two-sample hypothesis test for proportions using StatCrunch.